Hello, everybody. Today we're going to go over resistive inductive parallel circuits and their formulas. For those who are in my current spring 2022 class, we're using Delmar's textbook, 7th edition. Most of this can be found in Appendix B, page 930. Some people probably have the 4th edition who aren't in the classes right now, because if we've been around for a while, we probably have. I have 2nd edition, but this is what I went through. But 4th edition, you can find Appendix B on 1028. So we're going to discuss resistors, a resistive load, and an inductive in a parallel. So when we're talking about this, the only place you're going to find something like power is with the resistive load. When we're talking about a similar thing to power, it's volt amp reactance, and that's with your inductor. And when we talk about what we would in a resistive circuit call power, it cannot be power here because of volt amp reactance, so it's volt amps. There's a power factor, which is a percentage, and then angle theta, which deals with vectors. Right now, I just need anybody who's taking my class to understand angle theta, how to find it. And then Z is for impedance. We're still using manipulations of Ohm's law based by using impedance, and volt amps is when we do volt amps, that's a manipulation of the power formula. Volt amp reactance is another manipulation of the power formula, where, as we've discussed before, XL is inductive reactance and it's expressed in ohms. Its unit of measurement is ohms, similar to resistance. In a parallel setup, as we find our totals or our givens, we can use any of these formulas as we need to with the information that's given in order to find the missing values. So you'll see this is a simple version of a parallel circuit. This one is a little more complicated. So with this, we have 2 resistive loads in series that are in parallel with 2 inductive loads that are in series. It could get far more complicated than this, but we're not going to go there yet because we don't need to at this point. So while we're working out things like this, remember, inductance is L represents inductance. That's henries. E is volts, amps. There isn't a unit of measurement there, and ohms. Total impedance is ohms. Volts, amps, and VA, just those two together. And this is expressed as a percentage. And this is as an angle X degrees. If you need to figure out how to work it out, like I said, you can find all the formulas. There's more formulas than this in Appendix B. Okay, so this is going to be the example for the parallel circuit, our resistive inductive circuit. We're going to have 6 ohms at R1, 3 ohms at R2, 0.01 henries at L3, 0.03 henries at L4. While we're working this, we need to find our inductive reactance. So to do this, 6.28 times 60 times 0.01. So that is XL equals 2 pi FL. 2 pi is 6.28. F is frequency. In the United States, frequency is 60 unless otherwise stated. And then L, in this case, is 0.01. That's 0.01 henries. In this case, 0.03. So calculating XL3, it's 3.77 ohms. And for XL4, it comes out to be 11.3 ohms. Since they're in series, I can add the XLs together. So my XLs 3 and 4 is going to equal, is it 15? 15.07. Yep. And then my resistance is going to be 9 ohms. So I'm just going to write 15.07 ohms here for XL 3 and 4. So I know, remember that's the combined portion. I'll get rid of this, get rid of this. Now I have the combined of each branch. I'm going to use this to find Z. I could use this, but I'm going to use this formula. So in this case, it's going to be 9 times 15.07 over the square root of 9 squared, which is 81, plus 15.07 squared, which I'm going to figure out with my handy dandy calculator. Which is 227 is what we're going to use. 227.1. So 227.1 I gotta clear that. Gotta make sure I do this right. I'm always used to doing this the old ways. So it's 17.55. So 17.55 9 times 2.07 equals 135.63. That's divided by 17.55 equals 7.73. So my 7.73 ohms. So my total impedance is 7.73 ohms. Now I'm going to do is multiply that by 10. It's going to be 77.3 volts. So it's 77.3 volts for 1 and 2 combined, and 77.3 volts. Now I'm going to go for current. And since this is just an exercise in Ohm's law, 77.3 divided by 9 gives me 8.6. I'm rounding. So if you come up with a much larger, whole lot more decimals, just realize I'm rounding. 8.6 amps. And then 77.3 divided by 14. I don't know what I wrote here. It's 15.07. Gives us 5.1 and 5.1 amp. All right. So I can find my total power here as well, right? Because I know that my I12 is 8.6 amps. So my power is going to equal 8.6 times 77.3. That's going to give me 62.87 watts. And then to get my VARs, is that's where I'm going to multiply my 5.1 times my 77.3. $394.2. Now, for my volt amps, all I've got to do is multiply my amps and my volts together. So that's going to give me 773 volt amps. Now I have 773 volt amps. And to find my power factor, I'm going to check the book, make sure, go over here to the appendix, go to parallel circuits, look for power factor, and power factor we can use is power over volt amps. So we can use power over volt amps, which we have the power here, and we have the volt amps right here. So we're going to take 62.87 divided by 773. And that's going to give us 0.816. We're going to turn that into 0.82. So it can be written as 0.82 or it can be written as 82%. That's our power factor. So with our power factor, we know it's 0.82. With our power factor being 0.82, we need to find angle theta. So to find angle theta, we should be doing 1 over sine of gotta find the example of the book. It's not on this page. It's just like this. You take clear. There's clear. So we're doing cosine. So we're going to do 0.82 did it backwards this way. Yeah, I'm looking up to make sure I did it right, because something doesn't look right to me there. 34.9. So cosine theta, or angle theta is 30, angle theta, 34.9. Okay, that's right. I did not make a mistake. So, and I'm always cognizant. I always try to look it up in the book, make sure I'm not making a mistake. That's why I recommend, well, that's why when we give the test in most of my classes, unless it's otherwise designated by the institution where I'm teaching, you get a reference sheet that you make yourself, you can bring in, because memorizing all of this, I've been doing this kind of stuff for years, and I still look it back up to make sure I'm not making a mistake. But this is how you work it out. So you find all your information. This is Ohm's law, so I'm not even going to mess with that. This is Ohm's law again, so you should be able to solve all that out yourself. So I think this should do it. And I'm going to stop the recording now.